Hi, these are your TAs Ankit and Sehaj, and this is the Friction Lab.
In case you forgot from last time, here's how you turn on the computer.
First, you want to measure the length of the board. So you take your metric ruler, you measure the length. I don't always use the metric system, but when I do, I'm doing a physics lab. The next thing you want to do is select one side of the board, because each side, one rough and one smooth, have two different coefficients of friction. So once you've selected a side, pick the smooth side, you put the block on top on the edge. Align it so you have the exact length. Once you do that, you then want to raise the board to the point at which it reaches that static equilibrium. Keep it steady, and then either with your partner, who should film you, or with yourself, you measure with the ruler. The next step of the lab is to then take the other side of the block to measure its static coefficient. So last time we did the rough side, so now we'll do the smooth. Last time you want to align it, center it on the board, and then raise it until that static equilibrium is overcome. Measure it as such. For the analysis of this part, what you're going to first want to do is find this angle. To find this angle, remember we recorded the length and the height, the opposite leg, and then you can easily find the sine of that theta value. Once you do so, then you can use that to find then the coefficient of static friction.
Now get out the only sensor that Bellarmine has given you for this year, the motion sensor. Plug it in as such. Put the motion sensor at the end of the wooden ramp. Then measure 0.2 meters from the end of the ramp and draw a line with pencil here. Place the block after this line. Open Data Studio. Attach your motion sensor as the first port. Then double-click Graph and open the velocity graph. Now let's learn how to scale the graph. But before we do that, let's remove the negative time, because that doesn't exist. At least not in Physics B. Then adjust the scale by moving your mouse over to the actual scale and moving up or down. Moving up makes it more zoomed in, and moving out or down makes it zoom out. So zoom in to about what seems to work for velocity graph. We start with the experiment. What we have to do is raise the block to different heights and record the velocity graphs for each height. So let's start with this trial. The velocity graphs, to find the average acceleration, we need to do a linear fit. The way to do that is to select certain data points on the graph, hit the fit button, then hit linear fit. You should see this pop up. Now put all the data into this graph. When you're doing the analysis, remember that you have to use these equations to show the work that you did.